I'm going to make some of you angry by claiming that Argo CD synchronization logic is wrong. The way Argo CD works is great, only if you have very simple scenarios, and more importantly, if you have a lot, and I repeat, a lot of patience to define orchestration. It tries its best, yet it was designed wrong from the start, so many of the attempts to remedy issues feel like workarounds that force us, the users, to put more work into it than necessary. Argo CD is broken. As a matter of fact, I will even claim that the way kubectl and Helm work is also wrong. But unlike Argo CD, there is a good reason why those should stay as they are. Today's session will be a practical hands-on exploration of the order and dependencies related to deployment of Kubernetes resources. We will see that both kubectl and Argo CD are doing it the wrong way. I will even claim that the way Argo CD operates is against some of the Kubernetes core ideas. I will also show a few examples of the tools that do take the right approach and are more in line with Kubernetes core principles, especially eventual consistency. All in all, kubectl is doing it the wrong way, but that's okay. Argo CD designed the synchronization mechanism badly, and that's not okay. Fortunately, there are tools that do deployments and synchronization the right way, and we will see an example, maybe two, later. Hence, today's TLDR is that one of Kubernetes' favorite tools, Argo CD, messed up from the start. I have a love and hate type of relationship with it. I love it because it's probably the best GitOps tool we have today, yet I hate it as well because it causes me to do more work than I should do. Let's get going. Let me show you what I mean by those outrageous claims. We'll take a quick break to introduce you to Twingate, the sponsor of this video. So here's a question. Are you tired of using VPNs, but you still want to work securely? If you are, this might be the time to ditch, remove, get rid of VPNs. They are evil. And then you can switch to Twingate. It allows us to access office networks and cloud or private resources securely without the headache of VPNs. It's easy to set up and it's fast, like really, really fast. There is a free tier, try it out, get rid of VPNs. And thank you Twingate for sponsoring this video, and now let's go back to the main subject. Let's start with a simple example. Let's say that I want to install an application packaged as a Helm chart. All I have to do is execute helm upgrade --install and pass a few additional arguments. That worked well, and I got Atlas operator up and running. By the way, if you're not familiar with Atlas operator, you might want to check out that video. The problem with that approach, as well as with using kubectl directly, is that we need to do things in certain order. We need to wait for some things to happen before we can do some other things. That's, in a way, silly, since that means that we, humans, are acting as orchestrators, even though Kubernetes is supposed to do the orchestration. Was that confusing? Let me show you an example. This is an external secret store. I won't go into details on what external secrets is used for. If you're not familiar with the project, please check out that video. Actually, it does not matter what that manifest is used for. What matters within the context of what we're exploring today is that we need to install the operator first. That operator will create a few CRDs, one of them being cluster secret store used in that example. Once the CRDs are created, we should be able to create the store. Hence, the logical thing to do would be to install the operator and apply the manifest, right? We can do that by executing Helm upgrade followed with kubectl apply. And that failed miserably. Kubernetes complained that it failed calling webhook. The reason for that failure is simple. By the time we told Kubernetes to apply the cluster secret store, the operator was not yet fully operational. So first, we need to wait until the deployment of the external secrets webhook is up and running, and wait and wait and wait. And once it's finished, apply the cluster secret store. We are so used to deal with dependencies and their orchestration that we often forget that Kubernetes is the orchestrator. Kubernetes should figure out what to do and when to do it. It should be a process inside Kubernetes that does what I just did. If something cannot be applied because there is no endpoint, or there is no CRD, or because namespace is missing, or because something else is not just right. Kubernetes should move on to some other resources and once the right conditions are met, get back to the one that could not be applied. Some of those issues can be mitigated with Helm hooks, by creating an Uber chart, by adding --wait and some other tricks. Nevertheless, those are workarounds rather than real solutions. They're meant to replace some of the functionalities we get through server-side executions of drift detection and reconciliation. However, I must stress that everything I said so far does not mean that kubectl, Helm, and similar client-side solutions are bad. They're not. They're doing what should be done, since they are executed on the client side. They're supposed to perform specific operations once. They're not server-side processes that are continuously monitoring the state of resources and performing actions necessary to converge them into the desired state. Helm is, first and foremost, a templating tool, and as such, its primary goal is to convert templates into YAML before sending them to Kubernetes API. Once that conversion is done, it acts in the same way as kubectl does. Both Helm and kubectl are ultimately sending a number of manifests to Kube API which might accept or reject them. If we would like to get a semblance of what should be the correct behavior, we would need to run commands inside those are executed in a loop. A loop. However, that's not what we do today. Those are some of many reasons why we moved synchronization processes inside clusters. That's one of the reasons why we adopted GitOps tools like Argo CD. GitOps tools changed the game. Instead of relying on CLI tools like kubectl and Helm to apply resources to Kubernetes clusters, they introduced server-side processes that pull manifests from Git repos and apply them inside clusters. All we have to do is push manifests to a Git repo and that's it. That's all we have to do. Argo CD, Flux, and others take care of synchronization. They will figure out the order in which the resources should be sent to Kubernetes API, and they will ensure that the actual state, the one that is in the cluster, in the clusters, matches the desired state, or what is in Git. There is only one problem though. That does not work without putting a lot of effort or manually specifying the orchestration. Here's one example. That directory contains Crossplane resources like providers, configurations, and a few others. Naturally, I would like Argo CD to do its magic and synchronize that to my cluster, which already runs Crossplane itself. Now, I will not go into details about Argo CD. If you're not familiar with Argo CD, you might want to watch those videos. Instead, I will show you the manifest that will ensure that whatever is in that directory is applied to the cluster. This is a simple one. Whatever is in the directory infra inside Kubernetes deployment demo repo will be synchronized into the cluster, and all we have to do, besides writing that manifest, is to apply it. Normally, this would be the moment I would move on to doing something else. I can trust Argo CD to do whatever needs to be done, right? The reality is quite different, and we can observe it through the Argo CD UI. Let me port forward the service, open it in my browser, log in, and enter the infra application. It seems that Argo CD is incapable of doing anything. It got confused. It does not know what to do with those manifests. You see, some of those resources depend on others. To apply a provider configuration, the provider needs to be installed, and for provider to be installed, Crossplane itself must be running in a namespace that was created in advance. All those are in that directory. But Argo CD does not know what to do with them. It's confused. Now, to be clear, Argo CD does try to order resources. It will try to create namespaces and CRDs first, custom resources second, and normal resources at the end. However, that does not always work, as it's evident from the example we are observing right now. The problem is not that Argo CD is often incapable of figuring out the order resources should be applied. Quite the opposite. The problem is that it tries to order them. By doing that, it assumes that the order will always be correct, and that's just silly. What Argo CD should do is to try to apply resources in any order, and if any of them fails to be applied, try again. Later. That's how Kubernetes works. That's how we accomplish eventual consistency. Yet Argo CD does its best once, and if that fails, it gives up. blaming me for not giving it more information. It blames me for not specifying waves and hooks. That's the silly part. That's the part I should not be doing, since that's the job of the orchestrator. That's what Kubernetes does. It will try to run something, and if that fails, it will try again and again and again until it eventually works. Argo CD is a quitter. It behaves like my daughter when she was younger. She would try something once, and if that fails, she would declare that it cannot be done. Argo CD, however, is not a child. It's a mature project that should know better than to quit on the first sign of trouble. Actually, it's even worse than quitting. Argo CD continues trying, but without trying again. It's locked in the first iteration instead of trying again. Fortunately, I know how to make Argo CD order resources. Even though that's a silly thing to do, I had to do it. It's unavoidable if you're using Argo CD. Maybe, probably, we'll see. Let me terminate the current process and show you yet another directory. I copied the infra directory and made a few modifications to the manifest. Here's the modified version of Crossplane. I had to add the sync wave annotation set to -1. That's a wave, and Argo CD goes from the lowest towards the highest wave. In this case, Crossplane will be applied before those specified as wave 0 or higher. Here's another one. Without the sync options annotation sent to skip dry run on missing resource, Argo CD would stop the process because the provider config CRD is not present in the cluster, even though that CRD will be created by one of the other manifests in that same directory. I won't go deeper into Argo CD sync waves. If you're not familiar with them, please watch that video. Instead, we will simply apply a modified version of the Argo CD application that will sync from that new directory instead. Now we can go back to Argo CD UI and observe that this time it seems, I repeat, to be able to synchronize the manifest from Git to the cluster, or at least that's what it looks like. The problem, however, is that I had to specify sync waves, sync options, hooks, and a few other things to make it work. That's too much unnecessary work, and all I wanted from Argo CD is to synchronize what it can and try again and again and again until all resources are synchronized. That's how Kubernetes controllers work anyways, and all I want is for Argo CD to do the same. Just as Kubernetes does not ask me where a pod should run, Argo CD should not ask me which resources should be applied first, which ones should go after that one, and so on and so forth. If I wanted to define orchestration myself, I would not be pushing files to Git, but doing it through old-fashioned way, by executing commands in a specific order from pipelines like GitHub Actions, Jenkins, Tekton, or whichever other I might be using for the stuff, right? Or I was using in the past. Now, it might take a while until all the Crossplane packages are available, so let's wait for them. Let's wait for a while until all settles in. After a while, all the packages should be available and we can continue. What I'm trying to convey is that we can make Argo CD do the right thing, but we need to put unnecessary effort. And even if we do that, there is no guarantee that we did it right. I would expect Argo CD to be based on eventual consistency. It should do what it can at the moment and then try again with those that it could not apply previously and repeat the process until everything is synchronized. Instead, Argo CD thinks that we should tell it what should go first, what should go second, and so on and so forth. That's silly. Now, you might say that you do not have a problem with doing all that. And you might be right, for now, at least. Your situation might be simple. Still, even if that is the case, I have a challenge for you. Destroy one of your clusters that is managed by Argo CD. Create a new one and try to synchronize everything, and I repeat, everything you had in the old cluster into the new cluster. Think of it as a disaster recovery exercise. Do you think that would work? Do you think that Argo CD will be able to synchronize dozens, hundreds, or even thousands of resources accumulated over time into the new cluster? More likely than not, it will fail. It will be stuck because a namespace or a CRD or something else is missing, even though that something is also stored in a Git repo. It will try to do things in certain order and fail. Now that I made you feel depressed, I can show you how I believe synchronization should work. I will use Crossplane to demonstrate how deployments to Kubernetes should be done. Nevertheless, today's video is not about Crossplane, and there are other tools that are based on the same principles, at least when management of resources is concerned. Hence, Crossplane here is to demonstrate how to do synchronization rather than to convince you to use it. If you're not familiar with Crossplane, you can always check those videos over there. Here's a Crossplane claim that creates and manages a Kubernetes cluster. Those 30 to 40 lines of YAML will create AWS resources like the cluster itself, a node group, a few subnets, a VPC, and others. As you can imagine, some are dependencies of others. A VPC needs subnets, and the node group needs a cluster. From Argo CD perspective, we would need to specify the order in which those should be created. There's more though. Some resources like secrets will be created in the control plane cluster, while others will be created in the new cluster. Some of those resources depend on others. Like in the example we explored before, there will be an external secret store that can be created only after the external secrets operator is up and running. There are quite a few things that will happen and resources that will be created. If you're interested to know more, I can explain what's behind that claim in a separate video. It's based on one of the most complicated and at the same time very useful compositions I created so far. So please let me know through the comments whether you would like me to explore it in more detail. And what matters within the scope of this video is that the resources behind that claim are more complicated and have more dependencies than a relatively simple example that failed to work with Argo CD without adding sync options and other tricks, right? We could and we should push that manifest to Git and let Argo CD synchronize it, but as an attempt to show you in as easy way as possible what will happen, I will simply run kubectl apply. While Crossplane is working towards creating everything required to run a fully operational cluster, I will show you yet another example. This claim will create an RDS database server together with subnets, VPCs, and other AWS resources RDS needs. It will also create a database inside that server, a secret in the control plane cluster, push that same secret into AWS Secret Manager, pull it into the cluster that does not yet exist even, apply a schema, and quite a few things. Just as with the cluster, there are many dependencies, and if we would like to accomplish something similar without Crossplane, like with kubectl or Helm or Argo CD, we would need to ensure that resources are created in specific order, that we need to wait for specific statuses, and so on and so forth. Still, we don't need to do any of those things. Instead, I will just apply that manifest. That's it. Let's take a look at what's going on with the database by executing Crossplane trace command. As we can see, most of the resources are failing. Most of the resources cannot be created because they depend on something that does not yet exist. That can be a CRD, information from some other resource, or anything else. None of those errors matter. Those are all temporary and can be interpreted as, I cannot do what you want me to do right now, but I will try again later. Let's see what's going on with the cluster. The current state is similar to what we observed with the database. Some resources were created, some are in the process of being created, while others are failing. And that's okay. We're looking at a process leading towards eventual consistency. Crossplane does not care about the order. It manages all the resources all the time, continuously. If some cannot be created right now, do you know what will it do? Do you know? Well, simple. It will try again later. Let's fast forward a few minutes and take another look at those resources. Look at that. That's magic of eventual consistency. Crossplane did not give up on resources that could not be created for some reason or another. Instead, it tried again and again and again until they're all available and they're all matching their desired states. We can observe a similar outcome with the database, which, among other things, had to push some secrets to that new cluster which did not even exist at the time. As we can see, all those resources became eventually consistent. This video is not meant to discourage you from using Argo CD nor to convince you to use Crossplane. I use Argo CD myself, and I do believe that it shares the best GitOps tool spot, probably with Flux. We don't have anything better, at least not right now. What I tried to convey is that even though it's great, it's not doing everything right. Every tool has features that can be improved, and the way Argo CD synchronizes resources is on top of my list. In simple scenarios, that does not matter. Yet there are cases when it does, and when that happens, the only option we have is to define sync options and hooks carefully, very carefully. So we can do it well with Argo CD, but it's not always easy, sometimes being even painful. What I'm suggesting is to change the default behavior so that Argo CD works with individual resources and simply retries those that cannot be applied. The important word in that sentence is default. I expect tools to have sensible behavior by default. And in case of Argo CD, the sensible default is to point it to a Git repo and forget about it. It's silly to expect people to define what goes first and what should be done last, when it should ignore CRDs during dry run, and so on and so forth. What I'm suggesting is for Argo CD to take a similar approach as what Crossplane is doing, and a few other tools. Crossplane is not the only one. Another important note is that Crossplane does not replace Argo CD. Don't think that me showing Crossplane after I complained about Argo CD means that one replaces the other. It doesn't. We need a tool that fills sync manifest from Git into a cluster, and we need a tool that extends Kubernetes so that we can convert it into a control plane. Those two work great together. And there are ideas they can borrow from each other while still maintaining focus on their own primary objectives. As a matter of fact, the winning combination that avoids all the issues I mentioned in this video is to create crossplane compositions and manage resources by pushing claims to a Git repo and letting Argo CD synchronize them into the control plane cluster. There's one important note though. There is no guarantee that eventual consistency will always work. Sometimes things fail. And when that happens, Kubernetes will be failing to create resources indefinitely, unless we implement some kind of a rollback mechanism. That's true no matter whether we are working with Kubernetes deployments, or with Crossplane, or with anything else. That's the nature of Kubernetes. It tries to converge the actual into the desired state indefinitely. We still need a mechanism that will notify us when something is not working as expected. The difference, when compared with other types of systems, is that we do not fire alerts the moment an error appears. Instead, we fire alerts and act on them when errors persist over a period of time. Thank you for watching. See you in the next one. Cheers.